In this video, we are going to see how to solve a system of linear equations by using matrix equations, namely AX equals B. Let's have an example. Write the system of equations as a matrix equation AX plus equals B. Then use Gauss-Jordan elimination on the augmented matrix to solve the system. So practically we are going to do the same. We are going to write an augmented matrix with the coefficient matrix here, results matrix here, and then by matrix operations we are going to have the identity matrix instead of the coefficient matrix, and then some numbers here so that we can say x1 is this, x2 is this, x3 is this. But before, let's write matrix equation. So the matrix equation is A times X equals B, where A is the coefficient matrix, X is the unknown matrix, and B is the results matrix. Now let me show you why we write in this form as a matrix equation. Let's substitute the matrices. So A is the coefficient matrix, X is the unknown matrix, and B is the results matrix. Now if you multiply A and X, you will see that you get the expressions in the system of equations which are on the left hand side. Let's see. Minus 1 times x1 is minus x1, plus 1 times x2 is x2, plus minus 2 times x3 is minus 2x3, and minus 2 times x1 is minus 2x1, plus 3 times x2 is 3x2, plus minus 4 times x3 is minus 4x3. And the third row, 3 times x1 is 3x1, minus 4 times, x2 is minus 4x2, plus 7 times x3 is 7x3. So this is the product matrix, which is equal to 2, 5, and minus 1, which is matrix B. So you see, when you do the multiplication, you get exactly the same expressions on the left hand side. So that's why we can write this linear equation system as a matrix equation, namely the coefficient matrix times the unknown matrix equal to the results matrix. Now let's solve this problem. So we will write the augmented matrix, and let's start the row operations. Now at this step you may stop the video and try to solve this on your own, and then you may check your answer. So first of all, I will multiply the first row by minus 2 and add to the second row. So I will have 2 minus 2 and 4 here, and it will be minus 4 here. Now when I add, I'm going to have 2 minus 2 is 0, minus 2 plus 3 is 1, and 4 minus 4 is 0, whereas minus 4 plus 5 is 1, and the third row will be the same. Then I'm going to multiply the first row by 3 and add to the third row. So it will be minus 3, 3, and minus 6, and here it will be 6. So if we do the addition, we will get, say, minus 3 plus 3 will be 0, 3 minus 4 will be minus 1, minus 6 plus 7 will be 1, and 6 minus 1 will be 5. Now if I add the second row to the third row, I will get this entry 0. Let's do that. So when we do the addition, it will be 1 minus 1, 0, and 0 plus 1, 1, and 1 plus 5 will be 6. Now I will multiply row 3 by 2 and add to row 1 to get rid of this entry here. So this will be 2, this will be 12. So it will be 2 minus 2, which is 0. And 12 plus 2 will be 14. For we have minus 1 and 1 here. And what we did was we added twice the third row to the first row. Now next I want to get rid of this 1 here, so I'm going to multiply the second row by minus 1 and add to the first row. Hence it will be 1, minus 1 plus 1 will be 0, 0 plus 0 is 0, so this will be minus 1 plus 14, which is 13. And the last thing I have to do is I'm going to multiply the first row by minus 1 so that the leading one will be positive. So it will be 1, 0, 0 minus 13, 0, 1, 0, 1, and 0, 0, 1, 6. Now we have the identity matrix here, hence I can write the answers as the unknown matrix x1, x2, x3 will be equal to the matrix B, which is minus 13, 1, and 6. So what we do is first we write a matrix equation and then we write our augmented matrix and try to get the identity matrix in the coefficient matrix part, and then we write the unknown matrix being equal to the result matrix. Now it's your turn. Please solve the following questions and show me your answers.